Every day, millions of dental restorations are performed around the world. One of the most critical steps is light curing, the process that hardens the restorative material and determines how long the filling will last. But what if I tell you something as small as the distance between the curing light and the tooth can determine the success or failure of the treatment? When insufficient light reaches the composite, it may not cure completely. This can lead to weaker restorations, micro-leakage, post-operative sensitivity, recurrent decay, and premature restoration failure. This challenge is especially common among dental students and newly trained clinicians, where maintaining the ideal curing distance is difficult due to limited visibility, restricted access, and the absence of real-time guidance. This question inspired us to do our innovation, which is the Smart Distance Guide for Dental Curing Light.
After identifying the issues faced during dental light curing procedures, we established three main objectives for our project. Our first objective is to ensure proper resin polymerization. Secondly, we aim to improve the consistency and the quality of dental restorations. Finally, our third objective is to provide real-time visual feedback. Our methodology began with the research and planning stage. First, we conducted a literature review and found that one of the common causes of inadequate resin polymerization is the inconsistent distance maintained during light curing. This inspired us to improve the conventional dental curing light by incorporating a smart distance guidance system.
Okay, now I will explain the hardware that we use. Okay, so our prototype consists of several main components. First is the electronic distance sensor. This electronic distance sensor continuously measures the distance between the curing light and the tooth. This sensor will send this information to an Arduino Uno, which acts as a brain of our system. Based on the measured distance, the Arduino controls three LED indicators: green, yellow, and red. Green indicator indicates the ideal curing distance. The yellow indicator indicates that the curing light is slightly outside the recommended range. Red indicator indicates an incorrect distance that may compromise curing quality. So when the distance becomes unacceptable, the buzzer also activates to immediately alert the user. This combination of visual, and audible feedback enables users to correct their positioning instantly. As shown here, this LED blue pen represents the dental curing light. As you can see here, the curing light is currently positioned too far from the tooth. The red LED indicates that the curing distance is outside the recommended range. At this distance, insufficient light energy reaches the composite resin. Next up, when I move this LED blue light slightly closer to the distance sensor, it serves as an early warning to the operator to correct the position or distance of the curing light slightly closer to the distance sensor. Finally, I will position the curing light at the recommended curing distance. Now, the green LED is illuminated. This indicates that the curing light is positioned correctly. At this distance, sufficient light energy can be delivered to achieve proper resin polymerization. This means that the operator can now confidently begin the curing process. Once the correct distance has been achieved, the operator presses the push button to start the curing cycle. The LCD then displays the countdown timer while the curing process is in progress.
So this slide shows the evolution of our prototype. We first developed a proof of concept using Arduino components to verify that our smart distance guide could accurately measure the curing distance and provide real-time feedback. After validating the system, we redesigned it into our final concept, which is an improvised dental curing light, where the sensor, LEDs, display, and buzzer are fully integrated into the curing light itself. The future product will feature a compact, ergonomic design that is lightweight, easy to use, and practical for everyday dental procedures, making it commercially viable.
Our innovation supports three sustainable development goals. Firstly, Wsdg 3. Good health and well-being by improving treatment quality and reducing the risk of improper curing. Secondly, Wsdg 9, industry, innovation and infrastructure through the integration of sensor technology into a conventional dental device. Our project directly contributes to Wsdg 3, good health and well-being. Proper light curing is essential for successful composite restoration. If the curing light is positioned too far away, insufficient light energy reaches the resin, resulting in incomplete polymerization and a higher risk of restoration failure. Our Smart Distance Guide helps overcome this problem by continuously measuring the curing distance. Our project also aligns with Wsdg 9, industry, innovation, and infrastructure. Instead of replacing existing dental curing lights, our innovation enhances them by integrating affordable sensor technology and a real-time feedback system. Using an Arduino-based control system and an ultrasonic sensor, we transformed a conventional curing light into a smart dental device capable of assisting clinicians during treatment. To validate our innovation, we reviewed findings from previous scientific studies. The first study reported that the operator's experience and technique significantly influenced the efficiency of light curing. Even when using the same curing light, inconsistent positioning can lead to different clinical outcomes. The second study showed that increasing the distance between the curing light tip and the restoration reduced polymerization efficiency become less light and it reaches the composite resin. These findings strongly support our problem statement and demonstrate the need for a system that assists operators in maintaining the correct curing distance. In summary, both research papers consistently show two important findings. First, the success of composite restorations depends on the delivering sufficient light energy to the resin, which is directly affected by the curing distance. Second, operator technique plays a major role in treatment consistency.
Dr. Hamzah, I'm from the City Medical Center. Okay, I always use the dental curing light during daily treatment lah. Okay, especially for fillings. Factors we consider important. Okay, for light cure, the factors yang important adalah the light intensity, the distance between the light cure dengan the composite, the filling. Lagi macam apa lagi, exposure time. Juga ada lagi lah banyak yang main factor lah. Okay. Of course, mesti pernah sometimes light cure tu rosak ke, dia tak betul fully functioning. Okay. Of course, mesti pernah sometimes light cure tu rosak ke, dia tak betul fully functioning. Okay. Realization lah. Okay, so the filling tak boleh keras ke, senang dislodge. Okay, so tu boleh fail. Yes, I think visual indicators can help. Macam kalau dia jauh, warna dia merah ke, kalau dia betul okay, the distance warna dia jauh ke. Okay. Nanti kalau buzzer, kalau vibrate dia macam okay, tapi kalau macam dia buzzer, maybe dia akan mengganggu patient, macam mungkin tak suka lah. Ini I rasa tak macam kita buat braces bonding, macam banyak bracket, so I think kita boleh maintain the distance tu. Dia akan jadi okay lah, bracket tak senang dislodge.
In conclusion, our Smart Distance Guide offers a practical and innovative solution to improve dental light curing procedures. By ensuring the correct curing distance through real-time feedback, it helps achieve better resin polymerization, improve its restoration quality, and reduces the risk of undercuring. Our future vision is to develop this into a compact, ergonomic dental curing light suitable for both clinical practice and education. With further refinement and commercialization, we believe this innovation has strong potential to enhance the future of restorative dentistry. Together, we believe that a small innovation in technique can make a significant difference in the quality of patient care. Thank you.